Now we move on to question number 4, 5 and 6. These are easy questions. This is a triangle ABC in which angle C is already 90 and it's an isosceles right triangle. Isosceles right triangle means what? Two sides are equal. So obviously hypotenuse cannot be equal to any side. So this means that the base and perpendicular are equal. And what is the question? We have to prove that AB square is twice of AC square. So AB square is twice of AC square. So what we need to do is first apply the Pythagoras theorem. AB square will be equal to AC square plus BC square, right? And since it's an isosceles triangle, what happens? Instead of BC, I can replace it with AC. Okay, BC and AC are equal, right? So instead of BC, replace it with AC. So what will happen? BC square is replaced with AC square. So what will happen? You will get AC square as it is plus AC square, and therefore AB square equal to 2AC square. So it's a simple question. These type of questions may be asked for 2 marks. Then question number 5, again somewhat similar, but it's the converse. So here also AC and BC are equal. Again it's isosceles. And now here it is already given to you that AB square is 2AC square. And what we need to prove is that this angle C is 90. Okay. Here C was already 90. Here we have to prove C is 90. So AB square is 2AC square already given to us. I can split this into 2 parts. 2AC square can be written as AC square plus AC square. Now since it is given to you that AC and BC are equal, instead of one of the AC square, I can replace with BC. So AB square equal to AC square as it is, and this I have replaced with BC square. So AB square equal to AC square plus BC square, and we know that if sum of squares of two sides is the square of the third, then the angle opposite to that third side will be a right angle. So here AB square is equal to AC square plus BC square satisfies that condition. That means AB is the hypotenuse and the angle opposite to the hypotenuse will be 90. So conclusion, we can say angle C is 90, hence proved. Then question number 6. Here it's an equilateral triangle. It's an equilateral triangle, and what we need to find is that what is the length of this altitude given that each side is 2A. Now since it is equilateral triangle 2A, then what happens is that each side is 2A. So we know that the altitude bisects the base. So if this total is 2A, this is going to be A, right? This is A and A. Altitude bisects the base. Now this is a right angle triangle because we have drawn altitude, and when we use Pythagoras here, we get AB square is equal to AD square plus BD square. You can use Pythagoras here or here, it's up to you. So when I use Pythagoras here, 2A whole square is equal to A square plus AD square. This will become 4A square equal to A square plus AD square. Now A square gets transferred here, we get 4A square minus A square is AD square. So AD square is equal to 3A square. So AD will be root of 3A square. So value of AD will be root 3A. So length of the altitudes will be root 3A.